In this video, we're going to learn how to add and subtract rational expressions. We begin with a case where both rational expressions or rational functions or rational fractions have the same denominators. In order to motivate that, let us think for a second about an orange divided into 4 parts, in which I'm going to shade one part green, I'm going to shade 2 parts out of that 4 red. So let's say we would like to add 1/4 plus the 2/4. What do we expect to get? From the picture, that will be the total of 3 out of 4. Immediately, it appears that whenever we have 2 fractions where both fractions share the same denominator, the answer will have exactly the same denominator, but the numerator or the numbers on top will be added together to get 3. So, the idea behind this, which we just visualized, can help us to answer the first question, in which we like to find the lowest common denominator of 7 and 7. Well, for 4 and 4, the lowest number both 4 and 4 can divide into is 4. In the same way, you would say that the lowest common number, or the lowest number that both 7 and 7 can divide into, is 7 itself. And that can be very useful in order to compute the sum of 1/7 and 2/7. 1/7 plus 2/7, since both of them share the same denominator, just as we had in this case, 1/4 plus 2/4, it means that the answer will have exactly the same LCD, which is 7, and all we have to concentrate on is adding 1 plus 2, and that gives us 3/7. So what do you think, based on this fact, what do you think about 2/15 plus 7/15? Since both fractions have the same denominators, it appears that they will have the same LCD or denominator as part of its answer, and we can focus on simply adding the top numbers, which is 2 plus 7, and that is equal to 9/15, and we're done. Now, why have we spent some time on ensuring that we have a firm grasp of this concept? It is because in the following example, we're going to see how this is very helpful. This is a rational fraction, and this is another rational fraction. We would like to add them together. What immediately strikes us is that both rational fractions have the same denominator. And so, following the idea that we learned in this scenario and in these examples, we can readily say that the denominator for this answer will have the same least common denominator of x plus 7, which will be coming on the bottom here. So, with that said, since the denominators are the same, remember, when the denominators are the same, we can simply focus on the top numbers to get the top part of the answer. So in the same way, we're going to say 9x plus 14 plus x squared. And so that will give, since there is no number in front of 9x plus 14, we're free to ignore the parentheses, and so you have 9x plus 14 plus x squared divided by x plus 7. And this is same as x squared plus 9x plus 14, because we're writing in decreasing powers of x, from x squared to x and then to no x. divided by x plus 7. And what we need to check next is if both the top and the bottom will factor. What we find out is that the top will factor into x plus 2 and x plus 7, all divided by x plus 7. And since there's a multiplication here and a division, we are allowed to cancel off common factors, thereby leaving us with x plus 2 divided by 1, which is equal to x plus 2. And now we're done. We shall move on now to the next example. Again, we have a fraction and another fraction. We would like to subtract one from the other. What we quickly observe is that both fractions share exactly the same denominator. Well, that is good news for us because it means we can have the same LCD. The LCD is x squared minus 3x plus 18. That is the least common denominator, and that is coming right here as the denominator of the answer. And with that said, we are ready to focus on the top numbers, in which case we are ready to add 5x squared minus 7x plus 3 minus 4x squared plus x minus 9. So let's proceed to do that. So we have 5x squared minus 7x plus 3 minus 4x squared. Take note, the minus is distributing, so it has to distribute to each of them. So minus x and plus 9. And what would that help us? What would that lead to? Combining like terms, 5x squared minus 4x squared, we have 1x squared. And then we have negative 7x minus 8 minus x, and we have negative 8x. And then we have plus 3, plus 9, and we have plus 12, all divided by x squared minus 3x plus 18. At this point, we observe that while the top is factorizable, the bottom is not factorizable and will not lead to any common factors. So that means that at this point, this is only as far as we can go. So we proceed to the next question. In the next question, we have two fractions again, in which both share exactly the same denominator. So following the precedence we have, it means that we're going to have exactly the same denominator, which is our LCD. And with that set, we can focus on simply adding the top numbers, which will be 2w squared plus 8w. And with that said, we observe that these two terms have common factors, which is 2w, and then factoring that out, you have 2w into w plus 4 divided by, the bottom is the difference of two squares. So that will be w squared minus 4 squared, which can also be written as 2w, w plus 4, all over w plus 4 times w minus 4. And so we proceed to cancel out the common factors, and we have our final answer, which is 2w divided by w minus 4. And now we begin the next question. Before we do, there is something to observe about the denominator of the first fraction and the denominator of the second fraction. We have n squared minus 1, and we have 1 minus n squared. Take note that what differs in these two cases is that n squared comes before 1 in the first case, and 1 comes before n squared for the second denominator. This might remind you of a very famous factorization process because, as you might observe, this is simply negative 1 multiplied by this guy. So whenever you see this, for the purpose of this class, n squared minus 1, and you see 1 minus n squared, this is a question suggesting that you should substitute this guy with negative 1 times n squared before 1. Let us see how that is used in this example to make our work a lot easier. So, in this case, we have 2n squared plus 8n minus 1 all over n squared minus 1 minus n squared minus 7n minus 1. We're going to rewrite this as negative 1 times n squared first before 1. The reason why we're doing that is we would like the denominator here to match the denominator here eventually, whereas the minus here and this minus will merge together to become positive in the next line. So let's effect that. So we have 2n squared plus 8n minus 1 all over n squared minus 1. Negative divided by negative 1 divided by negative, that becomes positive 1. And 1 can be done away with. And you have n squared minus 7n all over 1. Minus 7n minus 1 all over n squared minus 1, which means at this point, both denominators now have exactly the same denominators. And that makes it easier to complete the addition because we can write the denominator as n squared minus 1, and then with the top, we can focus on 2n squared plus 8n minus 1 plus n squared minus 7n minus 1. So we have 2n squared plus 8n minus 1, and then positive n squared is still positive n squared, positive 7n is still negative 7n, positive negative 1 is still negative 1. That is because positive does not reverse signs. And so what we have next is 2n squared plus n squared, that will be 3n squared, and then plus 8 minus 7, that will be plus 1n, negative 1 minus 1, that will be negative 2, all divided by n squared minus 1. Now, we look at the top and the bottom. Would each of them factor? Yes, the top will factor further into n plus 1 and then 3n minus 2 divided by, in this case, n plus 1 and then n minus 1. So we seek out the common factors, which is 3n minus, which is n plus 1 and n plus 1, that takes out each other. And so we're left with final answer 3n minus 2 all over n minus 1.